Hello there, this is an Algebra 2 video. It is Chapter 10, Section 3, and today we're going to continue our discussion on series, this time going forward with geometric sequences and series. In the last section we were doing arithmetic sequences and series, and so we already talked about the difference between a sequence and a series. In the case of a series, we are adding up the terms in the sequences. And so we have a formula here for the nth term of a geometric sequence, and that is a sub n equals a sub 1 times, this is not a decimal point, it's a times, r to the n minus 1 power. And the a sub n represents the value of the nth term, a sub 1 is the value of the first term of the sequence, and r, of course, is the common ratio, which we can find by taking the ratio of a term and its previous term, as we did in the previous, in 10.1. So here's an example. It says, Julian sees a new band at a concert. He emails a link for the band's website to 5 of his friends. They each in turn forward the link to 5 of their friends. The link is forwarded again following the same pattern. How many people will receive the link on the 8th round of emails? So basically what we have going on here is that initially 5 emails are sent. And then those 5 people forwarded to 5 of their friends. So 5 times 5 would be 25. And then those 25 people would email it to 5 of their friends. So 25 times 5 is 125, and so on, and so on, and so on. So what we know is that the common ratio is 5. Whether you can see that because you're timesing every single term by 5, or if you take 25 divided by 5, you get 5, and 125 divided by 25 is still 5. So either way, our common ratio is 5, and our first term is also 5. So we're going to just go ahead and plug that straight into our formula. And so our formula says that a sub n is going to equal, let's wait for my pen here, 5, so it's going to equal a sub 1 times r, which is also 5, to the n minus 1 power. And in this case, we know that they want us to find the 8th round of emails. So we're going to say that a sub 8 is equal to 5 times 5 to the 8 minus 1 power, which is to say 5 times 5 to the 7th power, and then 5 to the 7th power is 78,125, and then if we times that by 5, we get at the end of the day that a sub 8 is equal to 390,625 emails on the 8th round. That is a lot of emails. So now we want you to try this do-it-yourself question, and then we will go on to our next example. And in this case, it wants us to write an equation for the nth term of each geometric sequence. So in the case of the first part A here, we need to figure out what the common ratio is. And if you take 2 and divide it by 1/2, you will get 4. And 8 divided by 2 is also 4. And 32 divided by 8 is also 4. So our common ratio is 4. Then we can plug it into our formula and call it a day. A sub n is equal to our first term, 0.5, times the common ratio, which is 4, all to the n minus 1 power, and that is how you do that. Very simple. In this case, in part B, we don't actually have the a sub 1 term. So we're going to use our sequence formula to find that value. We know that a sub 4 is 5, and we don't know what a sub 1 is, and we know that r is 6 to the 4 minus 1 power, because the n value is 4 in this case. So after we plug that in, we get that it's equal to a sub 1 times 6 to the 3rd power. 6 to the 3rd power is 216. So we get 216 times a sub 1 equals 5. Divide by 216. And now we know that the a sub 1 value is 5 over 216. Once we have that value, we can go ahead and plug it into our formula, which will be a sub n equals the a sub 1, which we now know is 5 over 216, and then times that by our common ratio, which is 6 to the n minus 1 power. And that is how you write the equation for the nth term of a geometric sequence. And now we would like for you to try this one on your own. And then we're going to go to geometric means. We also saw in our previous lesson arithmetic means, and geometric means are very similar. They are the terms between two non-consecutive terms of a geometric sequence. The arithmetic means was the same thing, but they were the non-consecutive terms in between two terms of an arithmetic sequence. So it's basically the same idea, only now we're doing it with a geometric sequence as opposed to an arithmetic sequence. So what we know is that we're starting with 2, and they want us to find the 3 geometric means in between them. So there's 1, 2, 3, and then we have 1250 as our final term. This means that we have a total of 5 terms, so n equals 5. So now I need to find the r value, the common ratio, and to do that we're going to use our formula. We know that a sub 5 is equal to 1250, and that in turn should equal a sub 1, which is 2, times the common ratio to the n minus 1 power. So we know that a sub 5, being that it's the 5th term, should equal 1250, and in turn, if we plug it into the the geometric sequence formula, it should equal 2 times r to the 5 minus 1 power. And we're just going to solve for r here. So this is going to be 1250 equals 2 times r to the 4th power. We want to divide by 2. 1250 divided by 2 is 625. And then to get rid of the 4th degree exponent there, we're going to take the 4th root of 625. And don't forget that when you take an even root of a variable, that you have to adjust, or not adjust, but accommodate for both positive and negative results. This will be plus or minus 5. All right? The square root of, or the 4th root, sorry, of 625 is positive or negative 5. So that means that 5 to the 4th power is 625, and negative 5 to the 4th power is also 625. So we're actually going to get 2 different options for this problem. So we're going to go with that, and we'll start with the positive 5. And we take 2 times 5, and that's 10. And 10 times 5 is 50. And 50 times 5 is 250. But also, if you took the negative 5, it could be 2 times negative 5 is negative 10. And negative 10 times negative 5 is positive 50. And positive 50 times negative 5 is negative 250. So you have actually 2 options for this problem. It could be 10, 50, and 250, or it could be negative 10, positive 50, and negative 250. So 2 options there. And now, that's how you do that, guys. So we're going to let you try to find the 4 geometric means between 0.5 and 512. And then we will go on to our next example, our next topic, which is, of course, to go into the idea of a series. As I mentioned earlier, in the case of a series, you are adding up the terms of a geometric sequence, and we have a formula for that. And the first formula is going to be helpful for us when you are given certain pieces of information. For the first formula, you want to use this formula when you are given a sub 1 and n. If you know what n and a sub 1 are, then you obviously want to use the first formula. But if you are given a sub 1 and a sub n, in other words, you don't know what n actually is, then you want to use the second formula. All right? So make sure you write those down, and we're going to go into our example 4. It says to refer to example 1. And if the pattern were to continue, what is the total number of emails that were sent in the 8 rounds? So remember, in example 1, we found how many emails were sent in just the 8th round. And that value, if you recall, was 390,625. But at this point, we want to know how many total emails were sent in all 8 rounds combined, not just the 8th round. How many were sent in the 1st round, in the 2nd round, in the 3rd round, all the way up to the 8th round. So now we want to add up all of those terms from the sequence. So to do that, we want to find the sum, the partial sum for n equal to 8. So we know if you go back to the original example that the first term was 5. A sub 1 is 5 because that's how many emails the first person originally sent. So then we subtract, the formula says A sub 1 minus A sub 1, so minus 5 again, times the ratio, the common ratio, which in this case is also 5, to the nth power, which is 8, and then divided by 1 minus r, which in this case is 5. So we're just going to plug it into the formula straightforward like, and then we are going to do the math. So we're going to get 5 minus 5 times 5 to the 8th power is 390,625. All right, so we're going to get that divided by 1 minus 5 is -4. And then we know that 5 times 390,625 is actually 1,953,125. And then when I go 5 minus the 1,953,125, we're going to get negative 1,953,120 divided by -4. And a negative divided by negative is going to be a positive 488,280 emails total in all 8 rounds. So if you added up the emails from each round, you would get 488,280 emails. And that is what they call going viral, right? So now we want to have you try do it yourself. Number 4, we're giving you, in the first one, you are given A sub 1 and you are given n. So you want to use the first formula. But in part B, you're not given the n value. So in part B, you actually want to use the second formula, which is that you use when you have A sub 1 and A sub n. So just keep that in mind as you do that example. And then we're going to go to our lovely sigma notation. And we are familiar with sigma notation already. So now we're just going to go and do the example here. So first thing we have to do is identify what n is. And because we're starting at 3 and ending at 10, we're going to go 10 minus 2, which is 8. So our n value is going to be 8. A sub 1 is going to be 4 times 2 to the 3 minus 1 power, because we're starting with 3, the k value of 3 for our first term. So 3 minus 1, which is going to give us 4 times 2 to the second power, which is 4 times 4, which is 16. So now we have our n value and we have our A sub 1 value, and so we just want to plug it directly into our formula, which tells us to do A sub 1 minus A sub 1 times the common ratio, which is 2, and then divide it, to the nth power, and in this case the n is 8, divided by 1 minus r, or in this case 1 minus 2. So that's going to give us 16 minus 16. 2 to the 8th power is 256, divided by 1 minus 2, which is -1. So 16 minus, and of course 16 times 256 is 4,096, divided by -1. And then we have 16 minus 4,096 is -4,080. When you divide that by -1, you get positive 4,080. So the sum for this example is 4,080. And so now we'll let you do yourself number 5. And then we will go to our last example for this lesson. And it's example 6. Says find A sub 1 in a geometric series for which S of n equals 13,116, n equals 7, and r equals 3. So we want to use our formula kind of backwards. We're given what the sum total should be, which is 13,116. and that should be equated to a sub 1, which is what we don't know, minus a sub 1 times r, but we do know that r is 3, to the nth power, and in this case the nth power is 7, divided by 1 minus r, which is 3. So now what we're going to do is we're going to get 13,116 equals a sub 1 minus a sub 1 times 3 to the 7th power, which is 2,187, divided by negative 2, because 1 minus 3 is negative 2. And then we can multiply both sides by negative 2, and that's going to give us negative 26,232 equal to a sub 1 minus a sub 1, 2187. All right? Now, because both of these terms have a sub 1 in them, we can actually factor out the a sub 1, or basically you can combine like terms. You guys know that when you have 1x minus some other value of x, you can just combine like terms. These are both like terms, but you can factor out the a sub 1, which will be 1 minus 2187. So a sub 1 times 1 is a sub 1. A sub 1 times negative 2,187 is negative a sub 1, 2,187. So we're just factoring it out. And then we can divide, because 1 minus 2,187 is negative 2,186. So we want to divide both sides by negative 2,186. And when you do that, that will cancel. You will get that a sub 1 is equal to 12. And that's what they wanted us to find in the first place. Find a sub 1. We have, it is 12. So it looks like my numbers over here got kind of crazy. This should have been minus 2,186. All right, just want to clarify that there. So now if you will do this do-it-yourself question, once you have completed this question, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.